second one, extrema on interval. Extrema means like a maximum or minimum in a plural word called extrema, okay? So objective, understand the definition of extrema of a function on an interval. Understand the definition of a relative extrema of function on an open interval. Find extrema on closed interval. That's what we're going to do. Extrema of a function. In calculus, much effort is devoted to determining the behavior of a function f on interval I. This interval means some interval a and b, two numbers, like 1 to 2, 3 to 10, some number, all right? Does f has a maximum value on I on that interval? Does it have a minimum value on that interval? Where is the function increasing? Where is the function decreasing? In this chapter, you will learn how derivative can be used to answer these questions. So using derivative to find your maximum and minimum. Not just looking at the graph, but you can find analytically because you know how to take a derivative. So definition of extrema. Let f be defined on interval on I containing C. Just some number, okay? It could be A and B, all right? So FC is a minimum of F on I when FC is what? Less than equal to F of X, which means this Y value is what? Smaller than other Y values. That's why it's called what? Minimum. Makes sense, right? Because your Y value is smaller than other Y values. For example, what kind of graph you can think of? Like that. And this right here is what? Your C. And your Y value, in this case, is your C, and F of C is what happens to be 0 and 0. Are you with me? So that's your minimum. That makes sense to you? All right, next one. F of C is the maximum of F on I when all your F of C is what? This F of C is greater than or equal to all the X values. Can I graph something similar to that? Which one? Like that?
Oh, thank you.
I'm gonna call it 4. Then my C is what? 0. What's my F of C? 4. So in this case, this is what your maximum. Does it make sense to class? Okay. And then we can have a minimum and maximum function on the interval are extreme value, or we can call it what? Extrema. Okay, and then you can also call what? Absolute minimum or absolute maximum. They all same meaning. And sometimes the extrema can be an endpoint if your interval is closed. So your interval matters. If your interval is closed, you have to check the endpoint. If the interval is open, then you don't have to worry about the endpoint. All right, this is a graph. You can see it. This is a minimum. Does everybody see that?
Yes.
You have this graph. It has, what is your interval? Interval is what? -1 to which number? 2. Does everybody see that? And this is a closed interval. Why? This is a bracket, which means this n value is what? Included. So this is a closed interval. If it's a closed interval, you have to always check the endpoint. So looking at this endpoint, where is the minimum located? Right here. Where's the maximum located?
Right there.
Right there. Does everybody see that? Oh, now let's look at the open interval. It's the same problem. The interval is -1 to 2. I have a minimum. Does everybody see that? But do I have a maximum? No, why? There is a maximum right there, but this Y value is what? Not included. Is that with me? Because it's open. So this case, this graph in open interval, you have a minimum, but you don't have a maximum. But does everybody see the difference? This is a closed interval. Everybody with me?
Right.
Closed interval, you look at the endpoints, and this endpoint has what? Maximum. So yes, you have a maximum, you have a minimum. Do you see the difference, class? Maximum, minimum? Are you following me, class?
Yes.
Colin, are you with me right now?
Mm-hmm.
Okay.
Mhm.
All right, now let's look at this one. All right, this is even more interesting. Look at this graph. This is another graph they're showing you. This is a graph of this, or this system of equation, the piecewise equations. Look at this graph. Do I have a minimum?
No, because it's
No,
open.
because it happened to be open. Oops.
Ooh. Oops.
Oops is right. Look at this big one. Everybody see that this one right here is open? Circles, I don't have a minimum. Do I have a maximum?
Yes.
Yes, where?
Close.
Right there, because it's closed.
I
Everybody
get
with
it.
me?
Yeah.
Okay.
It's cool.
So, what do you know? The extreme value theorem. It says if f is continuous on closed interval, then f has both minimum or maximum on the interval. For this case, I do have a closed interval, but I don't have a minimum because this value is what? Missing. There's a value where? 2 over there, but that is not a minimum.
Hmm.
Okay, relative, extrema, and critical numbers. Relative means what? Depends how you look at it, right? It's not absolute. The one that we look at was absolute maximum and absolute minimum. Now I'm gonna look at the relative extrema values. So looking at this graph, did everybody see? This one is what? Looks like a maximum value because this is higher than what? Other values next to it. Am I right, class? So relative means you look at this value to the left, look at to the right. If this y value is bigger than other two values, they're relative maximum. I'm only comparing which one? Over here and over here. So this y value is definitely smaller than this. Are you with me, class?
Yes.
That y value is definitely smaller than that one. So that is relative maximum. Where's my relative minimum? At the bottom. This bottom right here shows this is smaller than what? Compared to next one to next one. That's called relative minimum. Why is it relative minimum? Because this value, you look at this continuous function, it's keep going down, isn't it? So the smallest number is actually what? Negative infinity. So this is not an absolute minimum. It's a relative minimum compared to next two values to the left and to the right of y values. And again, this is not an absolute maximum. Why not? What happened to this graph over here? It's keep going to become a what? Positive infinity. So that is not absolute maximum, but this is what? Relative maximum. Does it make sense to you, class? Okay.
I'm learning.
Okay. So informally, for continuous function, listen to continuous function, that's an important word. Continuous function, you can think of relative maximum as occurring on a hill. It's going up here, isn't it? Right? And then what can you say? And the relative minimum occurring at where? Valley, going down this way. That's another way you can think of. All right. When the hill or valley is smooth and rounded, the graph has horizontal tangent line. This is an important thing. What horizontal tangent line means? Slope equal to what number? 0, that's right. Or I can say what? Y prime equal to what? 0. Are you with me, class? You just realize that, oh, I know how to do that then. In other words, if my slope is a 0, or my first derivative is a 0, then that's what? They have what? Either maximum or what? Minimum. You just figure it out. That's why chapter 3 is a continuation from chapter 2. So it said when the hill or valley is smooth and rounded, the graph has horizontal tangent line, which is same as slope equal to 0 or first derivative equal to 0. When the hill or valley is sharp and peaked, the graph represents a function that is not differentiable at the high point, which is fine. That case is also critical point. So this is a definition. Definition of a relative extrema. If there's an open interval containing C, C is some number x. Are you with me? It's some x. Which f of C is a maximum, then FC is called relative maximum of f, or you can say that f has relative maximum at C of f of C. So that is your maximum. So in other words, your graph right there is what? C, f of C, maximum. Next one, if there's open interval containing C on which f of C is minimum, then f of C is called relative minimum. The relative minimum, how it's write down, I'm going to call it C1. This is just C2, I'm going to call it what? C2, f of C2, that's your minimum. Okay, everybody with me? All right. Okay, also I can say what? Local maximum and local minimum. The other one is called what? Absolute maximum and absolute minimum. Okay. Look at this one. Find the value of a derivative at each relative extrema shown in figure 3.3. So this is my equation. I gotta take quotient rule to figure out what to do, or I can distribute it to make a power rule to do it. Okay, I will talk about it in a minute. So looking at this graph, I have what? Relative maximum at where some number n equal to what? 0. That C happen to be which number? According to this? C. C is equal to 3. That's your critical point. That's what they call a C. Stand for critical points. And here, my relative minimum is where? Right here. I don't have what? Derivative, because this is what? -1 is my slope. What's this one? N equal to what? +1. So they're not the same slope. So I cannot take a derivative, but you do have what? Relative minimum. Whenever you have absolute value, you do have that pointed thing is your critical point. Over here, you have a relative maximum and then what? Relative minimum. So I have not done anything new. I'm just giving you a new terminology using first derivative. So this, they're giving you this. All right, let's take a derivative of that. So this is kind of review for you because you learned this in lesson 2.4, doing a quotient rule. How do you take a derivative of this? What's the formula says? G squared, right? G times f prime minus f times g prime. So that's what they're doing. So I'm going to just write down what f is. F is what? 9 times x squared minus 3. What's f prime? You know, if you want, you can just write down this is what? 9 squared plus 27. What's f prime? 18x.
0.
Let's do g. G is equal to what? X to the third. So g prime is what? 3x squared. So I'm just going to plug into my equation. So I have a g, f prime. Is everybody with me? And then what? F, which is this, g prime, 3x squared, and g squared. Is everybody with me? I'm simply plugging it into my formula. So when you do quotient rule, write down your f prime, g, and g prime. Then what you can do, just plug it into your formula. Are you following me, class? You got to practice. It's not hard, but if you don't practice, you cannot do this problem. That's why I'm telling you, practice, practice, practice. All right. Now we're going to do simplifying, right? Because everything is everywhere, so we're going to simplify this.
Right.
All right, Daisy simplified right away. So how about I simplify a little bit slowly? Okay?
Yes.
Step by step. So what do you have here then? You have 18x to the what? 4. If you simplify this one, what do you have? 9 times 3 is give you what? 27x squared, and then you still have x squared minus 3. everything to the x to the 6. 3 times 2 gives you 6. Am I right, class?
Mhm.
Let's keep doing what? Let's do simplify one more step. That gives you 27x to the 4.
Mhm.
That gives you 27 times 3 gives you 18.
27 times 3.
1, 8, 6, 71. Are you with me, class? Are you following me?
Mm-hmm.
Look at the numerator. What's my common factor?
X to the.
The smallest number is second, right?
Yeah.
So this one I'm going to write it as second and second. And this one is also second and second. So I will bring out the second. Bring out the front. So x to the second is my common factor.
Whoa, whoa, whoa.
Are you following me, class?
I get it. Yeah, hold on.
You're not. Who said who's not following me?
Jennifer.
Just a tad bit too fast.
Okay. I just factor out x squared because you have x to the 4, x to the 4, and x squared. So you can factor out the smallest, least common factor, right? So square is the smallest number that I can factor out. So this one I don't have anything left. This one become a what? Second. That become a what? Second. Because I bring out the second in the front. I cannot factor out any numbers. Can I? 18, 27, and 71. Do they have any common factors? Not so sure. Is it 3? 3 goes in here, 3 goes in here, and 3 goes in here. Am I right?
I think so.
So I can factor out 3?
Maybe, hold on.
I think so.
71.
So I can rewrite this time as 3 times 6. This is 3 times 9.
That's 23.
3 times what?
23.
27. Oh, I can factor out 6 then. No, 9. Can I factor out 9?
No, wait.
I will do 9 then.
I like the second one.
No, 7 times 3.
Is it 9?
No.
27 times 3 gives you 81.
Right,
Yeah.
9 times 2, 9 times 3, 9 times 2 is 18. 9 times 3.
Oh, you
9
put
times
81.
this one. 9
Put
times 1 is
71.
71. 8. Right?
Hey, Dr. Harris,
Yeah.
27 times 3 is 81.
Oh, the 81?
Yes, ma'am. That's why I was like,
That's all I was just saying, yeah.
81. All right.
I'm trying to like,
All right, 81. Thank you. So can I do the?
yeah, now we
Is
get
that
it
the
now.
one at the bottom too then?
Yeah. that's-
Yes, yes. So do you want me to factor out which number? What's the common factor for number?
9, you do 9.
9.
9?
Yeah,
Okay.
9.
9 with 81.
That's what I'm
So 9 times 2, 9 times 3, 9 times 9.
Yeah.
All right, so I bring out 9, then I have a 9 in the front.
Okay. I'm with you.
So now this is only now what? 2.
2 squared.
The other one is now 27, but it's now what?
3.
3.
3 is
And then the other one is what? 9. All right. Now, am I done? I gotta do one more step. What is my one more step? This is x to the 6, this is x to the second. So how many do I have now then? Can I cancel this one out? That cancel out, this become a what? X to the 4. 6 minus 2.
6 minus 2.
Am I done now?
Two.
Wait a minute.
Yeah,
This is
yeah.
2 and 3. Can I combine this 2? What's that number equal to? Negative 1? Okay. Why do I even combine? I should combine right here, right, class? But it's okay anyway. I have a what? 9, and this combined together give you negative x squared plus 9. Everything over what? X to the 4. Well, guess what? I can factor out even more if I want to. This is what?
I mean, not
Class, look at this. Negative x squared plus 9. Can I rewrite it as 9 minus x squared?
yes.
Then this is difference of what? 2 squared, give you what? 3 times 3?
Yeah.
X times
X.
positive x, negative x, what I get what? 3 minus x and then what? 3 plus x and 3 minus x. I can rewrite if I want to. So my answer is actually,
You finna simplify it to?
if I want to, which is what? 9 and then what? 3 plus x and 3 minus x. Everything over x to the 4. So I'm done.
That was kind
So chapter 3 is a continuation of chapter 2. That's why I can moving on to chapter 3 lesson, because it does interfere with your chapter 2 studies, because it's continuation. Is everybody with me? Are you following me okay? All right. Now, what have we learned? It says what? To your maximum and minimum is at where located? You said what? Your maximum and minimum located where? Slope is what? 0, horizontal line. So which means I need to set them equal to 0 to figure out what my critical number is. So let's use it here. What was my equation? Tell me that I wrote it down. What's that? 9 and then 3 plus x, 3 minus x, everything to the what? 4. I'm going to set them equal to what? 0. To find what? Critical number. It could be 2, so I'm going to put numbers, okay? Critical numbers. Because it says the critical numbers, which is the maximum or minimum, is where? Horizontal line. Horizontal line means same as what? Slope is equal to 0, or what? Y prime of some c is equal to what? 0. Are you with me, class? That's what that means. They're all equivalent. So I'm going to say, okay, I know what to do. First thing, I don't want this denominator, so I'll multiply everything by what? X to the 4. But x to the 4 times this is still equal to what? 0. And then cancel out. So I have 9, 3 plus x, 3 minus x equal to 0. 9 does not matter, I told you that, right? You can just simply divide it by 9. It's still equal to what? 0. So my critical point is 3 plus x equal to 0, or what? 3 minus x equal to 0. So x is equal to -3, or x equal to what?
Positive 3.
Positive 3. So I have 2 critical points.
3 and 3.
3 and then what? -3.
I like that.
So I can plug this back into my regular equation to figure out what my y value is. This is just giving you critical points. I have 2 critical points. They are my critical points. Critical number, or I have 2 critical numbers. Is everybody with me? Okay. So I'm gonna go back to my other screen. So what happened to a lot of my students? I feel like I don't have everybody today. 1, 2, 3.
What's the week, what week is it?
So I'm missing like, I have about 16 students, I'm missing by 8 students. I don't know where they are.
We'll see on there.
Class, I know it's a homecoming week, but what you have to remember is what your primary job is what? Being a student, being a student, okay? That's why you have a homecoming. If you're not a student, you don't have a homecoming, are you with me? You got homecoming because you're a
You
student.
said that. Because they show up, you know that too.
All right, class, let's finish up this.
From the class, I just like this stuff.
Also, when you finish, do you see it? They're giving you, right here has your maximum. And -3 was over here, right? But that one does not have one because You have to look at the second derivative to figure out. But I will do that in next lesson. It's not in this lesson.
Alright.
Lesson 4, giving you about taking a second derivative to figure out whether you're gonna have a maximum or minimum or none.
Okay.
All right, now look at this graph. As you know, this is absolute value, so I have a negative one slope and positive one slope. So you have a minimum there. So you're looking at the negative side, you get negative one as your slope. Looking at from the positive side, you have a what? Positive one as your slope. And sine x, when you take a derivative of sine x is what? Just the cosine x, which is the easy part. So graph right here. Like you can see your graph is what? Keep continuing, right? So what do you know? Every time pi over 2, and over here is what is this one right here? 3 pi over 2, this is then what? Moving on to over here, what's that? This is 4 pi over 2, and over here is what? 5 pi over 2. So what's my pattern? Pi over 2, and then moving on to what? You adding 2 to it, right? So you get 5 pi over 2. So that's what they say here. All right, so your endpoint is 3 pi over 2. This is your minimum point. This is the maximum. Pi over 2, comma 1. My next one will be what? You adding how many? Adding 2 pi to it, which give you 5 pi over 2. And then what is your next one then? You adding 2 more to it. So 9 pi over 2. Are you with me, class? And you have so many maximum because this is what? Continuous function. Are you with me, class?
Yes. I get you.
So they have to give you interval. Say, hey, just find me a maximum on this interval. Then you have to give me which one. If they don't give you interval, then you gotta keep saying what? Pi over 2 plus what? 2 pi, or you can say 2n pi. I will tell you later. You don't have to worry about it right now. All right, note in example 1 that each relative extremum, the derivative either is a 0 or derivative is what? Does not exist. That's what they're trying to tell you. It's an important part. Your maximum, that is why your derivative is either 0 or what? Does not exist. Like here, does not exist. Here's what? 0. The x value at this special point is called what? Critical numbers, which we just figured out. All right, definition of a critical number. Let f be defined as c. If f prime of c is 0, or what? F is not differentiable as c, then c is critical number of f. We already know that either slope is 0 or what? It's not differentiable. All right, it's undefined at that point. Relative extrema occur only at critical numbers. If f has a relative minimum or relative maximum at c, then c is a critical number of f. So they are telling you, analytically, if you don't know how to graph, you don't have a way to graph, and you're not going to know where your maximum and minimum is, you can figure it out analytically by taking a derivative, set that equal to 0, and you find that x is your critical number. All right, finding extrema on closed interval. This is a closed interval. If it's a closed interval, you have to look at which one? The value of 2 endpoints. Are you with me, class? Because you may have your minimum or maximum and where? An endpoint. All right? So, guideline for finding extrema on a closed interval. Find the critical number of f. How do you find that? You're going to do what? F prime is like set equal to 0, right? And then find what? The x. That is your c, right? A critical number. Evaluate f at each critical number. And then evaluate f each endpoint. Find the list of this value is the minimum, and the other one is what? The largest number will be what? Maximum.
Okay.
So there's a step they're telling you, this is what you have to do. If it's a closed interval, you have to do extra 2 steps. Because you gotta calculate 2 endpoints. If it's open, you don't have to worry about the other endpoints. So you have this. So they gave you, I'm not gonna graph this, so when you take, by the way, chapter 3 exams, you cannot use Julia box. You cannot use your calculator. The reason is, you're supposed to apply your knowledge. So you can graph by doing the tools you learned. So your answer may not be exactly like accurate, but if it's roughly right, then it's right. Because it's estimating. Okay, and the numbers that I'm gonna give you, it'll be easy number to multiply. I'm not gonna give you like 237 times like 8, something that you have to do a lot of work. But it'll be like 3 times 2, or some number that you can calculate easily. Are you with me, class? All right. So define the extrema of f of x equal to 3x to the 4 minus 4x to the third. So they're asking you to find this. So what's the step they said? What? Take what? First derivative first. So step 1. Right, I got to f prime. So what's my f prime? So 3 times 4, 12x to the third,
Minus 12x.
minus 12x to the second. We got that? What's my second step? I'm gonna do what? You set them equal to what? 0. So I'm gonna say 12x to the third minus 12x squared equal to 0. My common factor is 12 and then x squared. Does everybody agree?
Yes.
So, and then what is my other one? X squared is my common factor. Everybody agree? Because this is x to the third, I can make it to x squared times x. X squared, so what's left with? X, and then the other one is minus 1. Set them equal to 0. So 12x squared equal to 0, or what? X minus 1 equal to 0.
X equals 0.
So x is simply equal to what?
0.
0. The other one is what?
This equals causing
So I have 2 critical number to me, right? Is everybody with me? I have 2 critical number. There's 2 critical numbers. What step 3 says? Step 3 says what? I have to find 2 endpoints, right? Am I right? Find the f of -1 and f of what? 2. So plug it in. F of -1 is 3 times -1 to the 4 minus 4 times -1 to the third. What does it give you? 3 minus 4 times -1 gives me 3 plus 4, which is 7. So at this point it's -1 comma 7. That's my point. What's next one? F of what? 2. Two to the 4 is 8. 2 times 2 is 4. 4 times 4 is what? 16. So it is 16 minus 4 times 8. 16 times 3. 48. Class, I'll let you use your calculator, that's fine. I guess you can use Julia box too, but on your exam, you cannot say, I got this graph from Julia box and I cannot give you credit. Are you with me, class?
Yeah.
You can use Julia box to check your answers, make sure that it's correct, right? But you gotta show me your work and so I find my critical point doing what? This work. Are you with me, class? Say yes, you can use your calculator. Yes, you can use the Julia box. But your exam, you cannot say, I got my graph came from Julia box. I'm gonna say, I will give you 0 points because this time you have to show your work, how you got the critical points, how you got your maximum, how you got your minimums and all that. Are you with me, class? Are you following me?
Mm-hmm.
So I need to see this work that I'm doing here. So I'm not done yet.
32.
32, so I get a what? 6, 16. So the other point is what then? 2 and 16. That's another point. So I gotta still find what? Critical points and here. We haven't done it yet. So we got the critical point, we didn't find the y value. So let's find the y value for this. So f over 0, what's my y value?
0.
For 0, that's an easy one,
Right.
right? What's f of, what's the other one? 1. So it'd be 3 times 1 to the 4 minus what? 4 times 1 to the third. 3 minus 4, which gives you what? Negative 1. So at here, what's my critical point? So 1 comma negative 1. That's what I have. At 0, what do I have? 0 comma 0. So this is the 4 things I have. So tell me what is my maximum? Where is my maximum located? By the way, this is a 16. So where's my maximum located? 2 comma what? 16? Okay, this is what I have, class. What's this? At x equal to 0, I have a 0. What else you have? X equal to 1, I have a what? Negative 1. X equal to negative 1, I have a what? 7. X equal to 2, I have a what? 16. So which y value is the biggest one? 0. So I know this is my what? Max. What is my minimum?
0.
Negative 1, isn't it?
My bad, yeah.
Negative y value, negative 1 is what? Smaller? So this is my what?
Me.
Minimum.
Say this.
So this case, your maximum and minimum is now located in a critical point. But where does it located? Your endpoint. Your endpoint has your minimum and maximum, yes.
Okay, you lost it when you did this over here with the F over.
Okay, so I find my critical number, right? Okay, the number is different from critical point. Point
Okay.
means you have x and y values.
Okay,
So I found the x value. So I gotta plug that into where?
the function.
The
Okay.
function to find my y value.
Mhm.
So my critical point, this is a critical point. Do you see the difference? Point is you have x and y values. Critical number means just the x values.
Okay.
So my critical point is 0 comma 0. So my critical number is 1. So I plug this 1 back into my function and I find my y to be what? Negative 1. Oh, so this is a, okay, I said it wrong, class. So minimum located where? Critical number, right? One of the critical number is your minimum. But the maximum is where located? Your endpoint. Are you following me?
Wait.
Right here, 1 comma negative 1 is your minimum.
Right.
Where's your maximum located? 2 comma 16, which is your endpoint. So when you have your endpoint,
I
you
see.
need to make sure you do all the things. Not stop at here, but go all the way to what? Finding that.
I have a question.
Yes.
So once you find everything and you put it in the little chart right there, to find the min and the max, do you just look at the y value?
Yes. I mean, I don't have to have this one. I just need this one such easier to compare. Yes. Yes. Did you see what she said? She's asking. She's like, we got 4 points to figure out, compare. So when you make a chart, it will be what? Easier to see, yeah. All right, so we're done for that, so. All right, so I want to look at this one, how they did it. So you can do what I did, or you can just make this one. Left point, critical number what? Right point, you get a 7, 0, -1, and 16. So you know, this is your minimum and that's your maximum. Remember, I made a little table, so this is what I made, this table. Which is fine. This table is even better to me because they telling you the left-hand point, the right-hand point, critical numbers. So you know you can clearly see this is your minimum and this is what? Maximum. This is another word saying as what? -1, 7. This is what? 0, 0, and 1, -1, 2, 16. That's what that means.
Same thing.
Yeah, that's the same thing. Is everybody with me now? So I have not done anything new. I'm just using what I learned from what? Chapter 2. And this is what the graph looks like. When you look at this graph, that's what it looks like. So you can clearly see that's your what? Minimum, that's your maximum.